Here we're asked to graph the following polynomial functions. Polynomials are nice because we basically just kind of get to sketch it. It doesn't have to be perfect, but there are some steps that we do have to follow, and we are going to be asked to have the correct y-intercept on these. So basically the only points I'll be looking for are the x and y intercepts. So to start, let's talk about the degree of this function. So the degree tells me that if I were to expand or to condense this all together, that can help me find the degree. When I talk about expanding, I know that x minus 2 squared is the same thing as x minus 2 times x minus 2. And so expanding helps me tell the degree because now I can just count the x's. 1, 2, 3, 4. So I get x to the power of 4. So it's a fourth degree. Now, if I was asking you to, figure out the degree and you like to multiply things together, well, I know x minus 2 squared. If I were to multiply that together, I would get x squared minus 4x plus 4. And then I have negative x and x plus 3. Then I'd multiply this x through to get x to the power of 3 and a bunch of stuff, and then multiply that by x plus 3, which ends up getting us x plus 4 plus a bunch of stuff. Okay, this method isn't as good. But I know here that this is a degree of 4, so what that tells me is the general shape after I look at the a value. The a value here looks like it is negative, meaning that a fourth degree polynomial usually looks like a w, but with an a value that is negative, it's actually going to look more like an m. So that's my general shape of this function. That'll help us kind of sketch in a little bit. Next, let's talk about the zeros here. So when I'm talking about the zeros, I'm looking at each of these pieces in parentheses and that x that's on the outside over there on the left. So the x that's on the outside, I know that if I plugged in 0 into these parentheses, it would make the whole equation 0, which tells me that that is an x-intercept. If I were to plug in 2 into this set of parentheses, it would make that set of parentheses 0, which when I multiply it through, makes the whole equation 0. If I plug in negative 3, same thing. So that gives me the points at which it touches my x-axis. So when I see here that the x minus 2 part is squared, I know that if anything is squared, if it's x squared or x minus, something squared, that at that point, it is going to bounce off of it. It is not going to go through. So when I am going through here, I know the general shape. So I'm going to start at the bottom left, and I'm going to come up through the first point, and then we'll deal with that in a second because I want to talk about the y-intercept first. With the y-intercept, I know that the y-intercept is when x is equal to 0. So I'm literally going to plug that into my equation here. So in this one here, minus x, x minus 2, x plus 3. And this one's nice and easy because I know that if I plug in 0 here, that 0 times all of this is going to still give me 0. I actually have already graphed my y-intercept. So this one is nice and easy, but sometimes you actually have to plug it in and do a little bit more math. So finally, sketching this here, I know my general shape here is an M. So I know I'm going through this first point. I know I'm going through the second point, and I know I'm bouncing off of that third point there because at x minus 2, so when x is equal to 2, it is squared, which tells us it's bouncing off that point there. So there's my sketch, goes through the y axis there at 0, and we're all set.